Hello friends, welcome to the Drive the World channel. Let us see the limit fit tolerance. In product design world, it is impossible to manufacture the 100% accurate part. It means if we take a dimension to maintain as it is 0, this is not possible to do. There is some limitations and need to provide flexibility to manufacture the part, and that flexibility called as tolerance. When manufacturer always try to approach true value or basic value of dimension within provided limit, and provided limit is always giving him help to reduce the rejection and part cost also. The article will provide the information about tolerance, limit and fit in engineering. And now, table of content, terminology, limit of size, engineering tolerance, engineering fit, system of fits and conclusion. Let us discuss the figure. First is basic or nominal sizes. This is theoretical exact size, and in this figure this shaft size is 4 mm. And now what is actual size? The actual size is real measure size on part, and this value lies between upper and lower size limit. And now maximum material condition means MMC. MMC is condition when on finished part contain the maximum amount of the material. That means on shaft largest shaft or smallest hole is MMC condition for both. And now example, MMC of hole is equal to 9.5 mm and MMC for shaft is 4.2 mm. And now least material condition means LMC. LMC is condition where part contain least amount of material. In the other words, smaller shaft and the largest hole is the least material condition. For example, LMC of hole is 10.5 mm and LMC for shaft is 3.8 mm. Next is maximum clearance. It means maximum space available between the hole and the shaft or between the two parts. The formula for maximum clearance is LMC of hole minus LMC of shaft. And now limit of size. Limit of size means the extreme permissible sizes for feature or dimension of part, and actual dimension of the measured part must be lie within this limit. Basic size is 4 mm and given tolerance is plus 2, plus 0.2 and minus 0.1 mm, and upper limit is 4.2 mm and lower limit is 3.9 mm. Engineering tolerance. As per ASME, tolerance in engineering is the total amount a specific dimension is permitted to vary from basic value. For example, if dimension is represented as 25 plus minus 0.5, its upper and lower tolerance value is 0.5 mm. Tolerance stack-up analyzed in use to ensure part assembly even in the worst condition. Why tolerance is required? Production of closely mating parts without tolerance is economically unfeasible. It results in increased rejection rate and manufacturing cost. Therefore, engineering tolerance ensure reduced rejection rate, smooth product assembly, interchangeability of manufactured part. Interchangeability means parts are made to specification that ensure that they are so nearly identical that they will fit into any assembly of the same type. And now types of tolerance. Engineering tolerance are further classified in following types. First is unilateral tolerance, second is bilateral tolerance. Unilateral tolerance. In unilateral tolerance type, feature dimensions are allowed to vary only on one side of the basic size, and in other words, tolerance lies only on one side of the basic dimension. For example, if a hole size is 20 mm and its value can vary from 19.85 mm to 20 mm, and the tolerance type is known as unilateral tolerance. It's used in defined precision fit. Unilateral tolerance is very easy to control in machining part. Operator to machines part to upper limit of shaft or lower limit of for hole. After machining the operator after machining the operator still has margin to further correction. Bilateral tolerance. In bilateral tolerance, feature dimensions are allowed to vary on both sides of the basic size. In other words, the tolerance lies on both sides of the basic dimension. Engineering fit. Engineering fits are used to achieve required product assembly. They define the clearance between two mating parts. And now types of fit. Types of fit. The dimensional tolerance value of mating part. Engineering fits are classified into three parts. First is clearance fit, second is interference fit, third is transition fit. Clearance fit. In clearance fit, the size of hole is always larger than the size of the shaft. Therefore, to ensure a clearance between mating part, clearance fit has a positive allowance. For example, the clearance fit include door hinges, shaft sliding inside a bearing inside ceiling fan, electrical switches and board etc. And now interference fit, force fit or shrink fit. In interference fit, the size of shaft is always larger than the size of hole. Therefore, it ensures interference between mating parts. Interference fit has negative allowance. For example, interference fits includes push fit insert in plastic part, axle and bearing assembly etc. And now transition fit. Transition fit is either clearance fit or interference fit. Therefore, in transition fit the shaft can be larger or smaller than hole. In mating part, transition fit is compromise between clearance and interference fit. Transition fit has overlapping tolerance zone of the hole and shaft. Therefore, they are used where accurate location is important, but small amount of clearance or interference is permissible. System of feet. To ensure required feet to ensure required feet, basic hole system and basic shaft system are used. Selection of type of system is done based on availability of standard parts and manufacturing processes. Basic hole system. In basic hole system, the size of hole is kept constant and shaft size is varied to obtain required fit. For example, minimum hole diameter is considered as the basic diameter, means basic size, from which the tolerance and allowance are calculated. Basic hole system is widely used because standard drill, reamer and used to produce hole. On other hand, the size of the shaft produced by turning grinding can be modified. Basic shaft system. In basic shaft system, diameter of shaft is kept constant and hole size is varied to obtain required fit. For example, in this largest shaft diameter is considered as basic diameter from which tolerance and allowance are calculated. The basic shaft system is used to standard sizes shaft.